Alright guys, let's look at the next two graphs on your sheet. So if you guys are looking at number 3, look at what we have in the numerator. When we get ready to factor that, hopefully you guys can see that we're going to have to use our bottoms up method because you can't factor out the 3, and when you multiply 3 to the negative 2, you get negative 6. So take a second to factor that, and hopefully you get the same factors that I do. You have x minus 2 times 3x plus 1. And we have over x minus 1. Nothing cancels, so there is no whole. Now for a vertical asymptote, we solve what's left in the denominator. We get x equals 1. And now let's think about our horizontal asymptote. Are we going to have a horizontal or are we going to have a slant? The degree in the numerator is greater than the degree in the denominator. So there's no horizontal. We have a slant. So I'm going to go ahead and put y equals because it's still going to be y equals. Now technically, since we're dividing by x minus 1 and the degree of that piece is 1, we can use synthetic division. But let me practice with you long division just in case you guys get a problem at some point, whether it's on your final, whatever, where you're dividing by like an x squared term or an x to the third. You have to use long division in that case. Okay, so remember, we think about 3x squared divided by x. You're looking at the first term of each piece. That gives us 3x. Now we're going to multiply 3x times the x minus 1. We're going to draw the line, change the signs, and we get negative 2x minus 2. Now we say what's negative 2x divided by x, and it's negative 2. So I'm going to distribute, and I get negative 2x plus 2. Okay, draw the line, change the signs. We end up with a remainder of negative 4. Now, we're only keeping this piece up here. So our slant asymptote is 3x minus 2. So let's go ahead and graph that vertical asymptote of x equals 1. That's here. Now let's graph 3x minus 2. So I'm going down to negative 2. The slope is 3, so I go up 3 over 1. Now remember, these are not points on our graph. These are just points on that asymptote. So let's draw it dashed. Okay. See if I can carefully extend that. There we go. Now, let's plot our intercepts to help us with the shape of our graph. So whatever factors are left in the numerator, we solve those for x, and we get our asymptote. So we have 2, 0, and negative 1/3, 0. So 2, 0, negative 1/3, 0. Okay? Oh, Miss Watson's silly. That second one, hold on a second, is not a y-intercept. Silly, silly. Negative 1/3 is here. There we go. Now let's look at our y-intercept. We substitute 0. We're left with negative 2 over negative 1, which is positive 2. Okay? Use your graphing calculator to help you guys find other points, because we want this to be a pretty good, accurate kind of sketch of the graph. Okay, so maybe we look at like negative 4. Let's go to the left a little more. Oh, that's too far down. So negative 3. I have it typed in my calculator. Negative 3 goes down to negative 10. So I can see this piece of my graph. Okay, be careful. I think I accidentally touched that slant asymptote a little, but you will not cross the slant asymptote. So then I'm going to go further to the right. I have 3, 5, and then I have 4, like 8.7. So here's the other piece of my graph. Looks kind of funny, but there we have it. So domain, we don't have any holes that we're skipping, but we do skip that vertical asymptote. So we're going from negative infinity to 1, union 1 to positive infinity. Now for the range, we don't have a hole that we're skipping. We also are going to extend up and down in either direction. So with that slant asymptote, it doesn't affect those y values. So we have all real numbers. So let's go to the next page and let's graph this next one. So in this one here, let's go ahead and start factoring. We get x minus 2, of course, x minus 2 times x plus 2. So these x minus 2's are going to cancel, and I'm left with 1 up top. Anytime everything cancels from one side of your equation, you're left with a 1. So that also means since x minus 2 cancels, we have a whole with an x value of 2 and a y value of 1 over 2 plus 2, which means 1/4. So 2 1/4 is about here. Remember, I make it pretty dramatic. Now my vertical asymptote is what's left in the denominator. So x equals -2. That comes from what's left, remember. So vertical asymptote at -2. Now check this out. Our degree in our denominator, you can look at the original function, it makes it a little bit easier. Our degree in the denominator is greater than the numerator. So that's when we have y equals 0 and no slant. So we have the x-axis as our horizontal asymptote, okay? And you don't have to draw the dashed over that as long as you know that that's where your asymptote is, because it doesn't hardly show up on your paper anyway when you try to draw the dashed. So let's find out our intercepts. There are no x-intercepts because if you look at your numerator, there's nothing left up there. And also think about this, your x-axis is your asymptote. So it doesn't always cross that horizontal or touch that horizontal asymptote. Sometimes it does, but not always, okay? Y-intercept, we substitute, 0 for y, for x. Oh my goodness, 0 for x. We're left with -2 over -4, or +1/2. So 0, 1/2. Okay? Take some time to find some other values. So maybe if we look at -1, we have 1 over +1. So we can see that right side of our graph. Okay, and I didn't do a good job making it approach that asymptote. Let me fix that real quick. There we go, a little bit better. Now on the other side, maybe we take an x value that's far away from the asymptotes. Maybe we look at -9. Okay, and I believe that gives us -1 over 7. Okay, you can use your table, you can use your calculator. Then -6 is like -1/4. Then maybe -3, we get a nice number at -1. So there's the other side of our curve. Okay? So remember, for domain, we're looking at our vertical asymptote and the x value of our whole. So from left to right, we start at -infinity. The first x value we skip is that vertical asymptote of -2. Then we go from -2 to the x value of the whole. Then we go from 2 to infinity. Okay, so basically, I've seen people do this before where they draw an asymptote here as well just to help them. Okay, so you would do that very, very lightly just to help them see the domain values that they're skipping. Okay, so I tried to draw that light for you. Now, let's look at the range. The range is going to skip over the horizontal asymptote, which is 0. Then it's going to go from 0 to the y value for the whole, so 0 to 1/4. And then we're going to jump over 1/4, and we're going to continue to infinity. Okay? So, let's keep looking. Put a check mark by each statement that is true. So I'm going to factor this first one just so we get a better picture of what's going on. Okay? So this first one says both functions have an intercept at 0, 0. Well, that's true for this first f of x, because if it's just x up top, that means that we have an x-intercept at 0, 0. And this graph also has an intercept at 0, 0 with that middle piece, so that's good. G of x has a horizontal asymptote that shifted 2 units, or down 2 units from f of x. Let's think about this one. We have y equals 1 as the horizontal asymptote. This one, since the degree in the denominator is greater, we have y equals 0. So actually it shifted 1 up for g of x, so we can't put a check mark there. F of x has a hole while g of x does not. Well, f of x does not have a hole, nothing cancels. They both have a vertical asymptote at x equals -3. Well, this one definitely does. We have x equals 3, sorry, that sounded funny, and x equals -3. Look at the graph. X equals -3, x equals +3. Okay, so that is true. It says a vertical asymptote. While they both have more than that, they still have a vertical asymptote at x equals -3. So you're using your properties and you're looking and comparing two functions given different images. Okay, one was a table, one was a graph, or one's an equation, one's a graph. Being able to compare them that way. All right, number 6, what is the horizontal or the slant asymptote? So this is where you use your tricks. The degree in the numerator is 2. The degree in the denominator is 2. So we divide the leading coefficients. So the horizontal asymptote is y equals 2. Okay? Remember, your denominator gives you your vertical asymptotes. The numerator gives you your x-intercepts. To figure out horizontal and slant, you have to look at your tricks and your degrees. Number 7, what are the x and y-intercepts? Okay, before we can do that, the y-intercept we can tell pretty easily. So for the y-intercept, we're substituting 0. So if we divide the constants that are left, we have -6/4, which simplifies to be -3/2. Okay? Now for the x-intercepts, let's see what happens in our numerator. So if we were to factor this, we have 3 times 6 is 18. So my two numbers that multiply to 18 and add to -11 are -9 and -2. But we have to divide those values by the 3 that we multiplied through. This is bottoms up. So we have x minus 3 times 3x minus 2 over, I'm rewriting this in factored form, x minus 1, or plus 1, sorry, and x minus 4. Okay, so this is really our factored form for that function. So our x-intercepts are coming from the factors in the numerator that haven't canceled. So we have 3, 0. Okay, and for the other one, when you solve it, you get 2/3. Okay? Let's go to the next page. What is the domain? All right, I'm going to stop here because I do want us to look at the graph as we do this problem. So I'm going to pick this up on a different video.